Welcome back to this next edition of the Home Lab series. So, I've got something cool for you guys. I tried recording this yesterday, and the problem that I ran into was the systems that are available to us for easy, free email alerting have changed substantially. So, I was stumbling through a video trying to figure out in real time what to do with this, and it was just so messy and convoluted that I scrapped it, and now I'm starting over. So this is the goal. This is going to be two more parts. So it's going to be this, and then it's going to be one more part following, where this is the little $99 PC that I made that, well, I didn't make it. I put the software on it, right? That I got on Amazon. It has a single port and a Wi-Fi adapter on it. So what I did was I got a little USB dongle, a little USB to Ethernet, and I made it a transparent bridge. So if we want to review again, Vim, let's see, Vim Etsy network interfaces. You can see here we have our loop back. This is the physical port. This is that big, disgusting name for the dongle adapter port. And then we put those and put them on a transparent bridge so that everything that's going in one ear goes directly out the other. And then I put that in line with my PC right here. So now I can generate alerts for testing. And then we also set it with a static IP address of .70 on my home network. So then we installed Suricata. So if we go to Etsy, Suricata, you can see here we've got our bunch of different rules. We've got the Suricata YAML file that we configured. So if we go back to rules, just so I can show you, we pulled down a tarball from emerging threats, and then these are the alerts that we want to use, and then we added a custom alert for ICMP for pinging 8.8.8.8 for us to be able to test the generated alerts. So those alerts are going to go to var log Suricata because it's running locally. It's not running in a Docker container. So here we've got 4 different logs. We've got the Suricata log, we got the stats log, we have the fast log, and then we've got eve.json. So let's tail each of these. Suricata.log, this is just what happens when it starts up. If you were to start it up from the command line, this is what it would print to the screen. If you weren't running it as a daemon, if we tail stats.log, this just updates every few seconds on like the total metrics for the device. And then if we tail fast.log, this is the one that we're really, really interested in. So I know it says TOR on here. I promise everything's fine. I'm not infected. I'm doing this for testing purposes, and I'll show you what I mean. But here you can see this is where all the alerts were generated. And in fact, if we do cat fast.log and I pipe it into less, you could see actually through the last several days, starting with the 28th when we ran this. It's now February 1st. It's been generating alerts based on traffic that it's been capturing the entire time. So it's a lot of like Discord and ET info, and there's some Spotify in here, ET policy. You can see I've got some like user agent update stuff for Linux and all that jazz, right? But how do you go through? Because you don't want to get notified every time there's a Discord, ET info, something like that pops up on your environment, right? Now it can be if you decide that you don't want anybody on your professional environment to have Discord, which is totally understandable, then that's something that you would want to be alerted on. So these policy alerts tend to be super duper noisy. These info alerts tend to be super duper noisy, like a Microsoft connection test. All that stuff's normal. It's not necessarily an indication of compromise. But there are some things that you definitely want to be alerted to, right? If there's like malware or attacks traversing across your environment, then you would definitely want to know about that. Excuse me, I'm getting a little sick after multiple days of not sleeping and staying up and making videos. But let's take a look at what it is that we had. So we enabled RC Local, which is going to run these things on startup, right? So it's going to start our Suricata every time when it boots up. And then it's going to start this thing. Of course, we haven't commented out, so it's not going to. The email alert.py. So this is what we're going to do. We're going to do this in two parts. Is one, I made a script. I'm going to walk you through it for the email alerting. And what this script does at this point in time is just pulls the relevant alerts that we want to see from the last 2 minutes. And then next time, I'm going to walk you through how to make your own postfix server, how to configure your own SMTP relay using a free service. And so we can actually send alerts to our email from this local box. So it would have been too much to all like put into one video. So we're just doing the email alerting. So here's the idea behind what we want to do. So maybe we'll go back to the fast log. Okay. We're going to do tail var log suricata fast.log. Notice each of these logs is structured. So it starts with like this is one log entry. This is one line, and then you have a new line entry. It starts off with the timestamp for it. Then it goes into like the version and the policy and whatever else. The actual name of the alert itself, the classification, the priority, the protocol, and then IP import and IP import, right? We can use this to our advantage. So if we say every time we run the script, well, right now is right now. So let's pull the time right now at the time we ran the script. Let's subtract 2 minutes from that, and anything in our log file that happened within the last 2 minutes in that 2-minute window, if one of these alerts contains a string of something bad, I want to know about it, right? And then what we can do is instead of just printing it to the terminal, we can just take that as the message body and put it in our email, and then send it along the way. It used to be that with Gmail, you could get an API key for less secure apps instead of having to go through the whole like OAuth thing through Google Cloud. But now they deprecated that feature as of literally last month. So now we have to create our own postfix server and go through an SMTP relay and get a domain and make DNS records, and all of that's just a little bit involved. So that's why we're going to make that a separate line item. So, but note how this whole thing is structured, right? So this is what we're going to do. We're going to import some basic stuff. OS to be able to see, does the log file exist? Time, because we're going to need to figure out our timestamps, and time is going to be for, because we're going to let it sleep for 60 seconds until it runs again. I don't actually have that part in here, but what I'm going to do is when I get to that point, I'm just going to make it while true, and then do that, and then time.sleep 60. Right, that's what the time library is for. That way it'll run, it'll do this function, it'll sleep for 60 seconds, and then it'll do it again. So how do we calculate in for the fact that we're going to be running it every 60 seconds, and it takes some amount of time to run this function right here? The way that we do that in the quick and dirty way is just run it every 60 seconds and then look for alerts in the last 2 minutes. So it's possible you could be double alerted on something bad. And, that is what it is. For most stuff in home environments, this is plenty. And even in some production systems, like that's also plenty. Because you could get into logging the alerts that you sent out specifically and then checking in those logged alerts relevant to that timestamp to ensure that you never get double alerted. But for what we're doing here, that's I think that would be more harm than good, right? I'm trying to give you guys actionable things that you can take away to make your own projects. And so the simpler, the better. Minimum viable product is the way that I like to do this, which is exactly why we are querying the fast log instead of taking all of our eve.json data and throwing it into a NoSQL database and querying the NoSQL database. That is what you would do in a production environment, though. So this is what we have. It's saying, first of all, does the fast log exist, right? If not, okay. So now we have this now is the current timestamp, date time.now. The time threshold is going to be now minus time delta minutes equals whatever it is that we have set up here, which we have set to 2. And then we have this alerts found array that we're going to add stuff into. So we're going to open this, we're going to read it, we're going to parse it one line at a time, and then we're going to split it to where our timestamp string is going to be just that first little chunk, which has it formatted like this without like the fractions of a second. That's why I've got the parts 0. So we're going to split it at the first space, and then we're going to take the first part, because when you split it, you end up with an array of like when you split it the first space, you end up with an array of like the first part before the first space and then the second part after the second space. Then we're going to take that first space and we're going to split it again at that dot so that we can consider just the first section of that and split off the fractions of a second, because we don't care about the fractions of a second for this purpose. And then we get our log time. So we're going to convert that into a date time object so that we can actually evaluate them in Python specifically. And if log time is greater than or equal to the time threshold, then we're going to look for any rule in line for rule in critical alert. So what it's going to do is, if this is satisfied and you have the for each of the individual lines, does it contain the string of this? Because remember, this was in each of those alerts, or if they were malicious, it would be in each of those alerts. And then we're going to append it, this thing up here. And so for each one, it's like, okay, one of those matched, we're going to stick it in here. Another one matched, we're going to stick it in here. It's going to go through and evaluate all of them. And then I have a value error that if it broke, tell me why it broke. The traceback.printexe is an amazing function. It'll tell you exactly what happened and why it happened and where it went wrong so that you can go through and troubleshoot and fix it. And then we are going to we're going to parse through this. So your alerts message is equal to joining all of your alerts with a new line entry, and then go through and do it that way, which is great. And then that's it. So now let me show you what happens when we run this. I'm going to break this. That's what it was. I was doing some testing earlier. So it's if alerts found is what we want, not if true. Otherwise, you could break it. That's super messy. Let's not do that. No critical alerts found in 2 minutes. Well, that's sad. Why? Didn't we have all this stuff in here? Oh, yeah, because we didn't have any critical alerts in the last 2 minutes. So what I did was I just got an IP address for a random TOR node. I'm going to curl that. By doing that, it should generate an alert, right? And if we look in here, we should be able to see, oh, take a look. This timestamp for like literally right now at the 32nd minute, it generated that alert. Hey, you have traffic going to a TOR node. Now, if that wasn't me doing this for testing purposes, that would be incredibly dangerous. That would look like a severe malware compromise. And take a look. Now, when we run it again, critical alerts found, ET-TOR, and then you have all of the information. So what could you do with this? Well, if you were creating a proper network detection and response platform, then after the alert, you would then want to come back and then find, based on this information, you'd want to go find it in the Eve log to get the full context and telemetry. So that was the one thing I didn't show you guys yet. Var log, Suricata, and then it's ugly. This is hard to see and hard to look at without either Pretty Print or without a NoSQL database. This is why Elasticsearch and Suricata go so well together, because Elasticsearch is a front-end visualization for Kibana is a front-end visualization for your Elasticsearch database. So then you can go in and you can see all of the telemetry. You can like follow the flows and do all of those things. This is everything that I did when I made my sim with the Elk Stack for my first company. This is a production level network detection and response platform that did very, very well. So the last thing that we're going to do is we need to, instead of printing this to the screen, we need to do like we can print that and then like send email and then that's all we have to do, right? I think this line is redundant, but all we have to do is just go through and send the email once we make that function. And the actual function itself to send the email is not going to be terrible. But if we, I'll do that one more time. The actual function itself is not going to be terrible for sending the email, right? It's just going to be actually configuring everything else, configuring the postfix server, configuring the SMTP relay, buying our domain, and setting our DNS records, and then we can send everything through there. But it's really just a couple of lines to actually go through and send the email. You just put your username, password, SMTP information, and then away you go. So I hope this was helpful. I will be posting this script to my GitHub. I'll put a link in the description. My GitHub username is evanlutz725, EVANLUTZ 725. Thanks for coming along. Let me know if you liked it. Hope it was useful, and I will see you guys in the next one. Cheers.